Hello and welcome back to EF2000 Retro. In the last video I gave you a general overview introduction to the EF2000 cockpit, and as announced I now want to show you how to start up the EF2000 aircraft. I'm using the ground ops training mission in EF2000 Retro, where we are once again using the EF2000 British single-seat aircraft. As you can see, we are parking on the ramp. We are not in a hurry, as there's no other activity in this mission. As the EF2000 aircraft uses F-16 systems modeling in general, albeit with customizations, the startup procedure is overall quite similar, but of course there are some specifics to the EF2000 cockpit. The fact that it is a twin-engined aircraft, the startup procedure has been tailored accordingly, and you can find the startup checklist on the kneeboard. There are in total 3 pages available for startup, pre-taxi, taxi, pre-takeoff and post-takeoff. You can find the same checklist in the EF2000 cockpit guide, so print it out. It's probably useful to have it. For this tutorial I switch the pilot model off and simply use a printed out checklist, and it is quite similar overall to the startup checklist or the training mission for the F-16, tailored accordingly. So the first step is to switch the battery on. The battery switch is located here on the forward systems gang bar on the right side console. So left click on the battery, switch the battery on. You see already some dedicated warning panel captions coming on, as we are now on battery power. The next one is we move the air source switch, which has been assigned to the ECS or Environmental Control System switch in the EF2000 cockpit. That's one here to the left side at the front of the right side console. That's a multi-state switch, so you have the different positions of off, ram air position, and also ECS normal position. We switch to ECS normal here with a left click. Now we can pre-configure our external lights. If you take a check of the aircraft, outside view, all lights are off. So we switch them on. This is external light normal position. I switch them to steady position. Anti-collision lights on. Formation lights on. It has multiple states for the formation light intensity, and here with this switch you can actually control whether the external lights are bright, dim, or also off, collectively off, so to speak. So I select the on position. Okay, that being said, we can also increase the console lights to the max position. In the next step we switch on the left boost pump with the left click here. That's the switch here, L boost pump, as we have only single engine systems modeling. We don't use the right one, only the left one. Then we can also start the radios or pre-start them with the left click. Set the generators on or preset them to the on position with left click here. And then we are already able to close the canopy. For the time being, we leave the canopy unlocked, and now we set for safety reasons the park brake. In principle we have chokes, so it's not needed, but it's always good to have it on once the chokes are removed. And now we switch the right LP cock switch on. In the real aircraft there are two LP cock switches for the right and left engines. The LP cock switch in the EF2000 aircraft is essentially enabling fuel supply to the engine and enabling the engine igniters. So left click on this one, it's on. So we now perform the left start engine. I typically enable engine display here in the upper left corner. So with the left click here, we select the left engine, and now we can we first need to start the auxiliary power unit. That's the switch here to the right side. Left click means start position. So here the APU spooling up. It will take a while before we see that the RPM will increase. Here in the upper left corner, you see already the APU caption is now on because it's running, but it's still spooling up. We need to reach 25%. As you have seen, 4 planes are now powered with hydraulics, so they come down. Wait until we have reached a stable RPM of 25%. Now we reach that state, so we can start the left engine. For this one, we perform a left click on the idle detent and cutoff switch. Right click would be cut off, so shutting the engine down. Left click would be start. So we make a left click and you can now see the RPM increasing. You also see that the 25% is actually displayed for the right engine, but it will go off once the engine has spooled up. Well, it actually does already. As already explained in the previous video, the throttle is not a split throttle, it's simply a single throttle motor driven by left engine throttle position, so it will move collectively. And now where we have the first engine started, we can switch to the next one. To do so, we select the right engine with a right click. And now we have to repeat this process. Of course, it's not realistic insofar as in the real aircraft you can of course start one engine with the bleed air of the other. I have actually implemented the right idle detent switch in a way that allows you to start up both engines simultaneously. So if you want to save time and not start up both engines separately and switch on the APU 2 times, then you can do this in one step simply by selecting both engines, starting the APU, and thereafter performing a left click on the right engine's idle detent switch, and then both engines will spool up simultaneously. I just wanted to show you how you can start up both engines individually, but you have both options of individual or simultaneous engine startup. So as you can see already, a lot of captions have been removed from the dedicated warning panel. We have now an FCS warning, so the flight control system isn't ready yet. But let's first start the header panel as it's equivalent to the data entry display. It's a left click on this control, as you have seen, may have seen or not. The bars moved from the off position to GPS. This is owed to the fact that GPS is automatically powered up. When the DED is powered, it takes a while before it comes online. It is very important that we switch on the CIU. In the real aircraft, the CIU means something else. In the sim, switching on CIU means that you essentially power the modular mission computer. As you can see now, there are some failures displayed here on the readout lines, which serves as a pilot fault list display. We also get an Avionics warning on the DWP, but that will be removed later on. Okay, the CSG switch here serves the purpose of powering or depowering the MFDs. So if we click on it, left click, you see both displays come on, and they're quickly powered because they are LCD type displays, not CRTs, so the power up time is very brief and short. So we can also already power the head-up display. We do this with a brightness wheel located here on the head-up display control panel, and we will now start to increase the audio volumes at this point in time. The MIDS A/B voice channel controls are actually used to increase the audio volume of the radios, and with it we also really power the radios up. Then we have the missile audio volume, the internal volume that will adjust the loudness of voice messages, for example, and of course the TACAN audio volume as well. We can set the amp control to normal position with a left click. At the moment that means it's the CNI control that switches to normal DED, or upfront controllers control, or backup control. And now initiate lens alignment, so the inertial navigation system or laser inertial navigation system. So for the EF2000, the EGI navigation option is selected. That means embedded GPS, INS. It's pretty similar to the real EF2000 aircraft's laser inertial navigation system. If you want, you can repeat the DED also on the HUD to keep on track what's going on. As long as alignment is in progress, we can continue with additional system startup. So to do this, we start on the right side console with the demist switch. We put on, that's actually anti-ice to auto position. In the EF2000 I have assigned anti-ice simply to the auto position and off position with a right click, so only two positions. In the real aircraft you don't have an anti-icing system actually, only an ice detector. that gives you a warning, but there's no probe heater available. So the air drive switch, that's this one. Let's move to auto position. That's the operations of the emergency power unit. Actually, we don't have the EPU in the EF2000, in the real EF2000 aircraft, but it is useful for the simulation simply for the simple fact that we are currently using F-16 systems modeling. It's single engine, so even if we can start up both engines and control both engines, the implications of an engine failure on the electrical system is simulated as in a single-seat aircraft, so to have the EPU, it's always useful to have it enabled, and ideally in the auto mode. We can also enable voice if we didn't have it yet, and proceed with the right side. The master arm and safety switch visible here is, so to speak, the power to the stores management system. Left click, radar altimeter on, ECM power. Here we leave it off for the moment. We can power up the radar. FLIR is not enabled, so it's not needed, and here is the IFF controls. So to the left side we need to power up the countermeasures dispensers. I am intentionally taking a look here at the center MHDD. You see it's empty at the moment. But if we power the countermeasures, then you see the C and F letters for chef and flare. It indicates that the dispensers are powered. There are no two separate switches for powering chef and flare, just this one control, which powers all dispensers at once. If laser designator pod would be loaded, a left click on that one would power the respective station and therefore power the LDP. We have none, so in this case we don't need it. So let's continue with the defensive aid subsystem. Once we have switched the lens to alignment mode, because lens alignment is finished. So now navigation is possible. We have full alignment, therefore full navigation accuracy. The DAS soft key here is actually powering the radar warning receiver. You can see the B letter here means the built-in test is in progress for the radar warning receiver. We have the normal mode indication. Okay, let's power the electronic warfare system itself. That's the DAS soft key at the top. It's currently in the off position, so depowered. Left click moves it in standby position, and you will also see that the chef flare countermeasures readout is now being displayed. The ECM caption here at the top only appears as if ECM is powered. If it's not powered, the ECM caption will be off. So let's move back just to showcase it. Right click, switch in off position, the ECM caption has disappeared. So that is the indication for you that ECM is not powered. Let's switch it on again. It's not. It's now being powered. You can run a missile launch audio warning.
Missile.
So what you also don't see is the missile approach warner symbol, because we haven't powered the missile approach warner. Left click here on powers it, and if it's powered, it will indicate the transmission symbol. Currently it's just eye candy because we have no missile warner implemented. But you see whether the MORPH is enabled or not in theory with this symbol. So let's now move to the FCS test to set up our flight control system. For this case it is useful to simply call up the FLCS page. You can do the stop step of FCS test before the power-ups that I've shown you, but it doesn't make much of a difference in this case. For procedural reasons, FCS would be tested first. In this case we have reversed this, but that shouldn't be a problem. Okay, let's first, that's very important before you perform the FCS test, get the error messages that are displayed here on the pilot fault list first. By fault acknowledgement we only keep the FLCS caption here. Then let's extinguish the master caution or attention getters. It is never bad to reset the FCS. So all faults are now cleared. At least all faults related to the FCS. So we can start to perform the FCS bit. To do so we simply perform a left click on this FCS test push button. The bit caption occurs and that means test is in progress. I recommend that you do not do anything else as long as the FCS test is running. So you see control surface start to move. You can switch to external view for a moment. So you see the light just extinguished. That means the FCS bit is over. We have no fault indications here, and bit pass is displayed. That means the FCS is ready to go. Dependent on your store's configuration, you should of course check whether the store's warning is indicated or not. You can set cut 1 and cut 3 through the config panel here on the FCS panel. A is in this case cut 1, C would in this case be cut 3, B is not used. Now you see cut 3 is the wrong configuration and we get the store's caption displayed. So let's switch back to cut 1 and the store's warning caption disappears because we have now the correct FCS config selected. So we can now proceed powering the mids. It's important that you don't power the mids too early because it needs lens alignment, it needs a valid GPS signal, otherwise it may not work. Let's switch to the IFF page. As you can see, it's currently in standby, and the other two soft keys here, int for interrogator, xpdr for transponder, in this cockpit they are used to select the normal and low power states of IFF. We select the normal state, so IFF's on. Reset the warning displayed here. Also switch back to normal HUD. In order to get the IFF caption removed, it's finally necessary that we load the data from the data cartridge. In the real EF2000 aircraft it's called the portable data store, but in the real aircraft mission data load is automated. Even if you have the automatic loading enabled in the BMS configurator, for IFF you seem to need to load this data from the DTE page, so it simply makes sense to perform load. Will of course take a while to simply load all the data. As you can see, IFF data are now being appropriately loaded, and the caption is also off. If you have FLIR fitted to the aircraft, you of course need to power it up. So the FLIR switch here, we don't have it fitted, so it's not required, but the FLIR alignment procedure is required, possibly if you're using that sensor. Same laser designator pod, if it's available, you have to power it up as previously described. If you want to get the mode 4 audio, then you have to use this ID push button. It's enabled by default, so you don't need to power it. If you want to depower it, right click on it, left click enables the mode 4 audio. So as required, set it. So as we have the helmet mounted display, it's enabled by default. You can of course use it, and if you're using it, don't forget to align it as per the procedure in the 16 user manual. For the time being, let's keep it switched off, we don't need it right now. The alignment procedure is exactly the same. For radio comms, we need to switch back to enable the normal operating mode that's achieved with the Bose legend here. Clicking on it switches to the normal CFI controls, and here on the left on the amp panel you can switch to backup mode of CNI if required, but as most of the backup functions are simply not implemented in the cockpit, at least not at this point in time, you can't really use it for the time being. Okay, then we have essentially finished the startup procedure, and we may now get in touch with the ground crew, telling them to remove the ground safety pin, to remove the shocks. Before we start taxiing, we will, as you can see, there are two warnings still displayed. We have to arm our ejection seat with the switch here. Caption goes off here, so the seat is now armed and no longer safe, and we need to lock the canopy through that switch. The caption is gone as well, so we are basically ready to go. The only thing that we need to ensure, enable your nose wheel steering. So now we establish contact with the tower.
Vapor to Singleton, EF2000, request taxi. Good morning, Vapor 2, you are number 1 for departure, taxi Alpha, and hold short, runway 21.
Okay, so pre-taxi also includes switching taxi lights on. Park brake off. Current will use an external view just because it looks a little bit nicer.
Vapor 2-1, what is your problem? You are disrupting traffic. Vapor 2-1, contact tower for takeoff. Switch to 29365.
So it means next channel 3.
Vapor 2, Singleton, EF2000, ready for departure.
Vapor 2, Haybrook Tower, wing 190 at 6 knots, runway 21, you are cleared for takeoff.
Important before takeoff, disable nose wheel steering. So you see the caption here goes out. So now we can go. Landing gear should be retracted quickly. Yes, and that's essentially what you have to do to get your EF2000 aircraft started and ready for takeoff. So I hope you found this video helpful for you, and then have a good time and see you next time for the next video. At the moment I'm still deciding what it will be. So see you and bye.